Hey everyone, welcome to Into the Bytecode. My guests today are Tim Beiko and Danny Ryan. They're two of the smartest people in this space and are the lead coordinators for the Eth1 and Eth2 development efforts. In this conversation, we go deep into the future of the Ethereum protocol. We talk about the merge, which is the most substantial Ethereum network upgrade to date. It's the transition from proof of work to proof of stake via the Beacon chain, and it's happening sooner than most people realize. We go into a lot of detail on how this is all going to work. We talk about the cryptoeconomics of proof of stake, MEV, staking derivatives, and how development works in a global project like the Ethereum protocol. We cover a lot of ground in this conversation. I hope you enjoy it as much as I did. I thought today we would spend the time talking about the merge, the Eth1, Eth2 protocol merge. And the Ethereum protocols, made a lot of progress in recent months. First with the Beacon chain launching, and more recently with EIP 1559 going up. And my sense is that the next big focus is going towards the merge. And so I thought a kind of easy place to start before we dive into deeper waters would be to briefly touch on what is the merge and why are we actually doing this?
So the Ethereum system exists. The Ethereum system launched many, many years ago now. You actually mentioned probably the two most substantial upgrades that have happened, like engineering efforts that have happened since the genesis, which is the creation of the Beacon chain and the reworking of the 1559 fee market, which is great. We really got some momentum going, a lot of exciting work being done. And now we're prepping for the merge. There's these terms Eth1 and Eth2, which represent really just different parts of the system that we're attempting to architect and modify and upgrade. Eth1 is the chain that we know and love. It has a proof of work consensus mechanism, and then it has the contents that we really care about as users, which are dApps, contracts, accounts, transactions, all that kind of stuff. And so then we have this other thing that we've been working on called Eth2. And Eth2 at its core is really the Beacon chain and all the features and things that we can do with the Beacon chain. The Beacon chain is a proof of stake consensus mechanism that we launched last December. It is really exciting. It comes to consensus on itself, but it's primed to come to consensus on other things. And so I mentioned Eth1. Eth1 has really two components we care about: the proof of work consensus mechanism, and then all of the valuable user layer, execution layer items. And really what the merge is the removal of that proof of work consensus mechanism from the Eth1. And so all we're left with is all the valuable things to users, and the swapping of that, the hot swapping of that in a live setting for the new consensus, the Beacon chain. So essentially the Beacon chain is coming to consensus on itself. The proof of work is coming to consensus on all the user layer stuff, chugging along. And at some point, at the point of the merge, the Beacon chain will then come to consensus on all of the execution layer, user layer stuff, and we will leave proof of work, energy hungry proof of work behind once and for all.
Yeah. And this has been such a long time coming. I feel like one of Danny and I's first conversations before either of us were working at the Ethereum Foundation was around proof of stake and, at these Ethereum meetups, and this being this distant thing in the future. And that's really what we're talking about, right? Moving from proof of work to proof of stake. Absolutely. And maybe also to touch on why this actually matters, what changes it results in. Before we go into the more technical details, Danny, I've heard you say that it changes security, sustainability, and scalability.
Those are my talking points.
Really yeah, I'm stealing your talking points. But what are the highest order bit changes on each of those dimensions?
So yeah, Eth2 is really an attempt to make Ethereum's consensus more sustainable, secure, and scalable while retaining decentralization. It's really easy to do those things if you make kind of what we would call very critical sacrifices. But we want to do that while retaining decentralization, retaining some of the core properties that we care about in the system. So the move to proof of stake, the merge, gets us the first two: sustainability and security. It is more sustainable because the cryptoeconomic consensus mechanism relies on essentially bonds in the form of Ether capital put up as the asset at stake, as opposed to the accumulation of physical hardware and burning of energy, which is essentially the analog in proof of work. And so to participate in that cryptoeconomic consensus mechanism proof of work, you just have to burn tons and tons of energy to prove that you're dedicating a scarce economic resource to the protocol. Whereas in proof of stake, I sign a message and I put essentially capital at stake and participate in the cryptoeconomic consensus mechanism. So I don't need to burn tons of energy, which is great. So more sustainable.
Yeah. So instead of actually, solving the quote unquote proof of work puzzles and getting X number of zeros at the beginning of the hash, now you just, you're literally signing a message. It's the energy usage is negligible, right? I mean, it will fall by 99.9% probably.
Yes, it will. And the core is that these are I said it before, these are cryptoeconomic consensus mechanisms. And so really they're proof of dedication of scarce resource to the protocol, right? And the scarce resource is energy and mining power in proof of work. And to prove that over and over again, you have to literally burn energy. And to take this native crypto asset and provide it to the protocol and have it at risk is much easier. I just pretty much like enter into a contract. I say, I'm going to play this game. I sign a message. And then if I play the game well, I make money. And if I play the game poorly, I lose money.
Is there some sort of an interesting chicken and egg problem here of the cryptoeconomic value of the collateral depends on the system being secure, and the system being secure depends on the collateral having value?
Tim,
How
what are
does
your
that
thoughts
work?
on that one?
Yeah, I think that's a great point. And I think Ether having value is definitely a prerequisite to moving to proof of stake, right? Like you couldn't, the absolute like kind of caricatural case is like if ETH was worth 0, you couldn't do proof of stake, right? And clearly, whatever ETH is worth today, we can do it, and it's kind of a gradient in, like from how it basically, as the value increases, so does kind of the security assurances of the system and the cost to attack the system. So it might not be like, it might not be a true relationship forever that like more value is better. And, but there is definitely some minimum amount of value that you need. And if you compare this to say proof of work, you see in proof of work, this threshold of value is usually being the dominant coin for your hardware class. So if, for example, you're like a GPU coin, such as Ethereum, you want to be the biggest GPU coin, because then any other GPU coin that's smaller than you can get attacked by just a fraction of the hash power. And similarly, if you're running an ASIC, you want to be like the biggest coin for that particular ASIC. And when you translate that to proof of stake, is you want basically the economic value that's securing the system to be large enough to secure how much value there is in that system. And Ethereum is interesting in that it doesn't only secure Ether, but it also secures basically every application that's built on top of it, right?
So how does that shake out as there are more and more applications built on Ethereum, with stable coins issued, fiat-backed stable coins, and really like the sky's the limit of the amount of value that can be on top of Ethereum?
Fortunately, there's a value accrual mechanism that translates usage of Ethereum into really fundamental value of ETH, because ETH literally is burned when other things use the platform. Yeah. So there's actually, there's a lot of, I don't want to get into the ultrasound money thing. I don't want to get into pump the bags thing, but like the native fee mechanism, market mechanism, having ETH very much enshrined actually helps at least add to the security that essentially you don't have a bunch of like freeloading apps in terms of like leveraging the security of Ethereum, but not really adding back to it.
Yeah, and one thing I'll add to that,
right.
So like, talking about EIP 1559 and the fee burn, one way I like to put it is, imagine you explain Ethereum to somebody who knows nothing about blockchain, right? And you're like, there's this blockchain which has applications that run on it, and the applications can like build coin and like hold economic value. Anybody would like assume that there is some mechanism by which the platform captures some of that value, right? They don't they maybe don't have an intuition for how it works, but it's just like you explain that to somebody and like their initial thought process will be like, well, you know, the more applications there are on Ethereum, like the more valuable the system will be. And they might not be able to say how, but like they'll have this intuition. And before 1559, that actually wasn't true, right? More applications on Ethereum didn't necessarily make the network more secure. And, you know, like when people paid high transaction fees, these basically go to miners, which are, you know, block producers with expenses denominated in fiat. So they need to sell those coins in order to pay back those expenses. And I think a large part of the reasons why, you know, the network has so much value is over time, you've seen Ether kind of become this unit of account or like store of value for a lot of applications. And you've seen this initially with ICOs in 2017, right? They held their treasuries mostly in ETH for a long time. And, you know, then you've seen it with DeFi that has started to use ETH as a collateral. So it's like we had some mechanisms by which they, you know, there was demand for Ether and that generates value, but we didn't have a mechanism that translated like more usage for the network into basically less supply. And obviously, again, there's a lot of caveats around like, you know, raising the price and whatnot. And there's a lot of volatility associated with cryptocurrency prices. But in general, you know, if you take a fixed point in time and you have, you know, the current supply times the current price equals the market cap, and you remove from that supply, you're obviously kind of going to increase the value of the remaining supply.
Right. And yeah. I'm almost never going to be talking about, especially in the short term, like price. Yeah. I'm talking about value, intrinsic value. You know, companies often will have like clearly they're building intrinsic value, but like their share price can clearly like map in the wrong direction for 10 years. Like I'm not claiming price movement when I'm talking about this stuff. And the move to proof of stake also, instead of miners, essentially, even without 1559, the block producer has access to fees and has access to anything else that it can be valuably produced by producing a block. And now that right goes to, or at least at the merge, that right goes to people that hold and lock up Ether. And so that's also kind of like helps kind of create the reason to have.
It's another source of demand for holding ETH and participating as a validator.
I did want to jump back a second and say, maybe the proof of stake, like kicking off that consensus mechanism, is circular in a sense, and maybe it's a bit more circular than proof of work, but I'd argue that it's very much circular in proof of work as well. Because why were the early people mining Bitcoin? Because they wanted Bitcoin. And then what's the byproduct of them mining? Making the network more secure. And then it's like there would be no reason, literally no reason to mine the first block or the 10th block unless you like wanted the Bitcoin for some reason.
Like there's just these people sitting on a corner mining some made up imaginary currency on their own, and no one
there's
cares
definitely
about
this like bootstrapping thing where like somebody has to want to do this because they think it's valuable, but it's not valuable because no one's done it yet. And then but the more people that do it, the more it's secure, and then maybe it's more valuable. And like, but I think you do kind of, you know, sort of like infinite loop kind of Gödel-Escher-Bach thing, where eventually it's like it is the system in and of itself because it got going.
It makes me also think of, I mean, many things of the world work this way. It makes me think of Sapiens almost, and the idea of these imagined orders that basically only exist in people's minds. And if they don't physically exist in the real world, right? Like the idea of money or a legal system is not a physical reality of the universe. It only exists because enough people believe in it. And if enough people stop believing in it, then it stops being real. And so there's this problem of how do you bootstrap these sorts of like shared hallucinations to enough coverage so that they become self-sustaining.
Yeah. And one thing I think that's interesting about Ethereum there is the fact that we did start with proof of work, I think was really valuable because you do see like a very different community around mining than around, say, users or holders or whatnot. So to take your analogy, Sina, it's almost like it bootstraps this idea in like a larger community's minds that we're able to like get this kind of stakeholder group that's part of the community and kind of bring them in early on. So I really like that, you know, Ethereum has had this proof of work period in its life, and I think it's brought in the community.
Yeah.
Longer than expected.
Yeah, that's fair. Yeah, everything.
When
is
Sina and
longer
I
than-
first met, I probably thought proof of stake was coming in like a year, and that was in 2017
Yeah.
or something. I was very naive.
And this, well, I guess this idea of proof of stake just having a larger footprint in terms of the number and diversity of stakeholders that are participating in it is part of the reason why it's more secure and more decentralized, right? Like anyone can participate from their own laptop anywhere in the world, versus, you know, proof of work where you needed to set up a mining farm, and that itself leads to the network being more robust.
Yeah, there are certainly many trade-offs and different design decisions on how these systems can be constructed. But I think one of the core reasons I would say it is more decentralized, and really the counter to, like, as the proof of workers love to say, it's just the rich getting more rich. And that's very a naive interpretation, because these are cryptoeconomic consensus mechanisms. The whole point is you put up capital in some form and you get a reward, right? And if you can make that function very pure and not have disjoint sections where if you put up more capital you get more reward as a fraction, then that's better. I mean, we're operating in the assumption that these are cryptoeconomic consensus mechanisms. You put up capital, you get a reward. And so in proof of work, if you put up a lot of capital, you can get very entrenched in supply chains, you can get hardware sooner, you can build custom hardware, and you can, like, actually per unit capital get more reward. Whereas in proof of stake, it's a much more pure function. It's like this very, very liquid asset. You can go to any local exchange. You can probably talk to your neighbor and maybe buy some ETH from him these days. And then you choose to stake or not, and you can utilize consumer hardware. And so pretty much, like, it's after the very small fixed cost of some bandwidth and maybe an old laptop, like, you are able to turn, post capital and get a reward just the same as the big guys.
Danny, you just mentioned, you thought it would be done in 2018. Maybe it's worth taking like a minute or two and explaining what's changed since 2018, because I think that the part around reducing the minimum stake is something that's probably underrated, and that other proof of work systems that are other proof of stake systems that are live today don't necessarily have. So yeah, like, why did Ethereum take these 3 extra years to ship proof of stake? What did we do in the meantime?
Right. So in 2018, we released an EIP called EIP 1011, hybrid proof of work / proof of stake, Casper FFG. And that was going to utilize proof of work as the block proposal mechanism, and then add a proof of stake finality mechanism on top, and then eventually get rid of the proof of work block proposal mechanism and have the stakers also propose blocks. The minimum stake requirement was going to be 1,500 ETH. And this is due to a number of reasons. One, I think there was a strange engineering decision to utilize the EVM for the core smart contract. So there was some amount of efficiency loss there, but some constant, maybe 2, 3x. But then around the same time when that was being specified, Justin Drake and Vitalik realized that these, like, cutting edge cryptography, BLS signatures, which allow for signature aggregation, could make this system, like, way, way, way more decentralized. And so that design, after much work, after clients were really actually beginning to put testnets together, was scrapped for a orders of magnitude better design, but one that was going to take a while, clearly. And that reduced the minimum stake requirement from 1,500 to 32 ETH, and still had, like, the same economic parameters that targeted, like, the similar amount of ETH. So, like, 10 million, 20 million ETH total stake. So now, instead of there being hundreds or early thousands of validators on the system, there are hundreds of thousands of validator entities. Each entity is exactly 32 ETH. So if I wanted to participate with 64, I'm 2 entities in the consensus, but nonetheless, I can participate with as little as 32. And I know many, many people that do on that kind of short range of 32, 64, etc. Granted, that number feels less and less small in USD absolute terms, but even then, it's been a mega boon for decentralization. And on the like 5-year time horizon, when you have global bandwidth increase, when you have the basic requirements of computers continue to increase and that kind of stuff, you could imagine cutting that in half when it kind of meets the similar requirements of today. And ideally that continues to be cut at least a few times, but we'll see.
That makes me think of one thing, which is like through the timeline of, you know, the Ethereum Eth2 and Serenity and the various names that it's had. I've personally actually been impressed by how the research community has actually decided to postpone where it makes sense, because, you know, and multiple orders of magnitude improvement is possible. And to the outside, you know, this has seemed at points like, okay, there's just no progress, like they're not shipping. But, you know, to me, it always seemed like these are actually sensible decisions being made if this system is going to live, you know, who knows how many years, hundreds of years, thousands of years into the future. And more recently, you know, I'm sure, like you both being involved in the engineering, like implementation process as well, me reading some of the discussions and the EIPs, it feels like this trade-off between being idealistic in the design and being pragmatic is almost like honed to a craft of its own in this process of like with the merge EIP, it really does the absolute minimum necessary, right? And there's going to be another EIP right after it to clean up some of the mess that's left behind. Like even those two pieces have been decoupled from each other.
Yeah, another thing we're also often seeking in design, and especially upgrading existing systems, is simplicity. Getting consensus is very hard, even with just a single client implementation. We have many, many client implementations. And so often it'll be like, you could imagine a feature that's really cool or like makes things a little bit better. And you're like, no, it is not worth writing that down and trying to get everything to be in sync. So we're also like, even though it maybe doesn't seem like it, the Ethereum system is complicated, seeking minimalism as well.
Yeah.
But yeah, Tim, I was going to ask what you thought about the craft of...
Yeah, I think we reach, you know, simplicity given our constraints, right? And the given our constraints is kind of the interesting part. For example, you know, like the typical all core devs EIP process is like somebody comes up with a new idea for a great feature and then they present it to all core devs and then it gets shot down because it's a denial of service vector. That's like the canonical thing. And then, you know, they go and they basically patch up their feature with a bunch of edge cases to like, you know, make sure that it's safe. And that intermediate spot, you usually get something that's quite clunky. And ideally, that gets, you know, iterated on and fixed, and we then come up to like a new implementation of it that usually is simpler and you know, addresses the security concerns. But it does seem like the fact that there are kind of these considerations around security that are much higher than like your typical software project, and the fact that it also happens in public, I think make it seem much more messy than you know, if you think about like just normal tech projects or tech companies, right? And like one example I think of, it's like, you know, if you think about like an iPhone or something like that, Apple doesn't show you like the 5 years of arguing and like having the prototypes open with, you know, the circuit board showing. And like for better or for worse in Ethereum, all of that is public. So I think it gets very easy to see like the messy part. And then when it's actually done, you know, I don't know, a lot of times maybe people don't pay enough attention to like the end result and saying like, oh, now it actually works. It's like the goalpost has been moved.
Right.
Yeah.
So, you know, as a semi-outsider of this process, as someone who follows it from a distance, to me, it seems like a just complete miracle that a decentralized, you know, a group of people who are working in different organizations and, you know, are working remotely, you know, getting together, talking asynchronously and on these calls, are making progress on one of the most complex like systems in existence and trying to upgrade it in real time.
Yeah.
I'll just agree. It is a miracle.
Yeah.
Like, I mean, I've seen engineering teams where there's, you know, a leader and they're all like working in the same room and they're trying to do something ambitious, and that's already impossible. That's, I mean, it's very hard. So what's happening here?
I agree with Danny. It is a miracle. And I guess, you know, my first thought is like, again, the fact that it's open makes it seem, it doesn't make it seem worse than it is, but like it makes it seem as it is. And like, I don't know, I like to compare this, like Ethereum is like a pretty big system now, right? Like it manages billions of value, if not trillions, if you count everything on it. Like, just imagine you're, say, an engineer working on something like Gmail or Zoom, right? Those systems are also like incredibly complex, and they need to, you know, like the user interface that's presented is much simpler than what's going on behind the scenes. And I think Ethereum is just like, the behind the scenes is visible for everybody to see throughout the whole process. And hopefully we keep the complexity small, but at some point it's like when the system has to like process a ton of things and work at scale, there is going to be some complexity. I think
it's not only visible, but I feel like if you opened up Gmail development, or you have Linux development, people use Linux. It's very important, but like most people don't follow it or give a shit. Whereas like you have this massive community of people that like follow all, like it's like it's their sitcom, like their reality show is watching all of this happen in real time. And I think that's because of I guess the relationship, like the monetary kind of relationship with the platform, and also because people like very much really believe in this like philosophically. And so you not only is it open, but everyone watches.
That's true.
I mean, it's also just really cool to be able to observe something like that. I mean, it's not even limited to Ethereum core development for me. It's a bunch of projects in the space where you can just hang around in a Discord, and some of them are more open than others. And like, you can literally see a very interesting, you know, ambitious protocol get built in front of you. And you would only have that sort of a front row seat if you were inside of a traditional company, usually.
Yeah. Agreed. And I think my one goal with regards to this process, like in the medium or long term, is I do want it to seem less and less exceptional. I think it was Rick Dudley had this comment a while back saying, like, you know, if your process requires if your process requires genius every time to work well, you don't have like an engineering process, you have like an artistic process. And I do think that's like a fair criticism of like Ethereum development. And you know, we can't have that today. Like, there's just so much moving parts to the system and so many big changes coming. But I think over time, it would be awesome if we were in a spot where like the process was a bit easier for people to follow and to contribute to, and perhaps required less of like these kind of artistic displays.
I don't know. It's part of the charm.
Yeah,
there are a lot of artists around too.
Yeah, something I want to go back to is the how, and Tim started touching on this. One, like everything is viewed, every potential change is viewed like incredibly with like security first mindset. And so it's really easy to cut out a ton of the crap and to prioritize because of that. Like, we're always going to prioritize something that makes the system more secure than like a feature if we have to. And then the second, I think, is that there is like a very strong ethos and philosophy, and this, which it is coupled also with the fact that like the system isn't quite what we need it to be yet. And so there's this drive for progress. And so, yes, there are like incredible people that do some incredible research and lay down roadmaps and things like that. But the willingness to kind of bite in and to continue forward is really like this ethos of like, this isn't done. We have something good here, and we can make it. We can make it what it needs to be, but it's not quite there yet. And so you combine that with like the security ethos, and like I think that's kind of what keeps us moving.
Right. And it really is a long time horizon, right? Like, to this point, there's been a lot. And even from today looking forward, there's many years worth of like very interesting and hard and, you know, impactful technical problems that need to be solved, like with the merge and way beyond. There is a bunch of other stuff after.
Not to mention, we're in like an applied cryptography renaissance, where like every 6 months there's this like radical new technology that when you combine it with cryptoeconomics, is like seems like literal magic. And so like the stuff that's going to happen with virtual machines and zero knowledge proofs and stuff for the next few years, it's like it's a lot of stuff coming.
Yeah. So I think maybe let's take this transition to start talking about the merge specifically. What is this actually going to look like? Like what are all of these people that we're referring to working on now and over the next months as we get to this milestone?
I think it's important it's probably valuable at this point to discuss the separation of concerns and layers and how this is kind of a happy accident that's happened. So what we call Eth2 or the beacon chain has been architected in relative isolation from the existing chain. And what has happened on the existing chain, like the proof of work consensus mechanism is very stable. It's very fine. Like if you go look at the diff across Geth the past 5 years, they probably haven't touched it very much at all. But all the optimizations has been in this execution layer, running the EVM very efficiently, managing state, doing sync, all that kind of stuff. So we have like very sophisticated pieces of software to do this. And then in parallel, we've created very sophisticated pieces of software to come to do proof of stake consensus with hundreds of thousands of participants, all sorts of cool stuff going on there. And so we have these teams and these pieces of software that are actually pretty specialized. And so the whole framing of the merge and specifications, and even how it's going to look in engineering, leans into this separation of concerns and such that we have the consensus layer, or the proof of stake consensus layer. It has its own specifications. Then we have a link into the execution layer that has its own specifications. And we also have two pieces of software. Essentially, think about Geth. You have Geth, all the EVM and the state and stuff. And then you have this like this brain, this proof of work brain that's like driving it. It's saying like, hey, this is the head, this is a new block, that kind of stuff. We can take that brain, we're gonna do brain surgery, or maybe we're gonna switch, we're gonna keep the same body and switch the brain. But you can take that brain out, and instead of listening to proof of work, we can listen to a beacon chain client. And we can actually like keep these as two pieces of software that run in harmony together. And the beacon chain software essentially is driving the execution layer of Geth or Nethermind or any of those other clients. And so what it looks like is teams on both sides of the aisle coming together, creating the link between the two. You know, that EIP you saw is really that like the link between these the proof of stake consensus layer and the existing execution layer. And so now it's really like refining that link, ensuring that the core of the execution layer that we know and love, like state sync and that kind of stuff, can continue to operate with this new brain, and bringing it all together and testing and doing test nets and beating it to hell, and then going to launch. There's a lot of other details in there, but that's kind of at a high level.
And maybe one thing I'll add about like why this is possible and like desirable is at the very beginning, Danny mentioned that I forget your three keywords. You have sustainability, scalability, and the third one,
security. You gotta know the talking terms.
Yeah, exactly. Yeah.
It's a good one. It's hacked into my brain.
Yeah, and then this merge gives us the sustainability and the security. And a lot of people look at the original roadmap of Eth2, and there's a big focus on the other S, like the scalability. And one thing that's been really interesting to see in the past year and a half or so is the rise of rollups on Eth1. So I think as the work on the beacon chain kind of happened, we launched the beacon chain, and that went live. It was great. The original roadmap was like, well, then we'll do sharding, and then eventually we'll add computation to those shards so that they can bring us scalability. But we're starting to see scalability just happen on the base layer that we have today via rollups. And that kind of simplifies a lot the design, where if we only need to kind of take care of these two S's for now, we can do the merge and also rely on all of the rollup teams to kind of scale Ethereum for the users. And eventually we can get into that later. We'll have shards, and that'll help kind of make rollups cheaper. But the kind of general work around scalability can kind of be outsourced to those teams. And that's like a super valuable development that I think is sometimes underrated because it
I like
it
to
frees
say
up
that
the protocol teams.
I like to say that the roll-ups are buying us time.
Yes.
So we can
exactly.
carve out those W2Ss.
It feels like there's almost two kind of big aha moments that happened, right? One was the realizing that the existing Eth1 clients and these Eth2 clients are actually like
harmonious,
complementary, and can really be coupled together in a really nice way. And the other was basically realizing that we have rollups and we can switch the order of the merge and sharding. And then even when sharding happens, the first part of it is going to be data availability shards that aren't, intelligent, can execute things. And that also couples. So it's like there's like two kind of big realizations. And I remember the roll-up centric kind of realization where, when Vitalik, I think, talked about it at an Eth Global event and was talking about it before a little bit as well. But how did the two clients and realizing how they could interface with each other, how did that come about?
I mean, I did write an ETH research post that talked about like client separation and leveraging these components. It's something that we probably had talked about for some amount of time before, but for me, it was really the like, just the like there were some proposed roadmaps that essentially scrapped the EVM, scrapped all of the work that Geth and Nevermind and Beiko have done for years. And just like that did not seem palatable from almost any perspective. I mean, for one, like it's much more of a forced migration. Two, it's like we have these incredible experts, blockchain experts, and we're just gonna like try to scrap their clients and try to move on. And then like, and so much of that. And so really that was the motivating factor on me, was like, this all needs to come together in a much cleaner way. And that pushed in that direction. But, there were glimmers of that over the past like couple of years, but it really started coming together, I think, with the post talking about how these clients can be separated. Because at that point, Guillaume started doing some R&D and did like a proof of concept along with Mikhail to show that, oh, you can actually do this. And that really picked up steam from there.
And well, maybe let's spend some time on just talking through how this double client architecture actually works, because I feel like it's pretty interesting, especially given that the transition is going to happen within a live network, right? And so I think the latest designs that I saw, and I may be wrong here, but they kind of, there's the beacon chain that's coming to consensus on its own state. And at some point you basically take the state root of the execution chain and you put it into here, right? And it's a first class citizen inside of the beacon chain. And these two clients are going to be running on the same machine and communicating with each other via some, RPC protocol. What are the brushstrokes of how this is actually going to happen?
So yeah, I mean that's the core. Essentially, upon some condition, probably at some sort of like terminal total difficulty on the proof of work side, the validators on the beacon chain pick a final proof of work block, reference it, and build upon it. So essentially, the valuable user layer payload, which is transactions, is shoved into a beacon block, and as one of the items that is come to consensus on is also the post state root, which is essentially like the Merkle digest of what the state did. And that the way that works from a engineering perspective, once say let's operate, we can talk about the actual point of merge, but like the merge has happened, the validators on the beacon chain, they build a block, like they're called upon to build a block, and this is the beacon nodes, this is the consensus layer side, and I have an execution engine running, which was an Eth1 node running in conjunction with me. It knows about state, it's been managing the transaction pool, pretty much everything like in the user layer, and I'm called upon to produce a block. And I do my regular validator thing. So maybe include some attestations, maybe include a couple validator deposits, but then I get to the execution stuff. So like, essentially I want to create a valuable payload, a user layer, execution layer payload for this block. And so I'm gonna say, hey, local Nethermind instance, give me a valuable payload. And it's very equivalent to, like, right now there's on the JSON RPC, there's a couple of proof of work methods. So one is called get work and one is submit work. And it's essentially give me the hash. And this is what third-party miners build their software on. Essentially, it says, hey, Geth, give me the hash of something valuable to mine on, like a bunch of transactions, and then it mines on it. And then if it finds a solution, it submits it back. And so it's kind of similar in that I go, hey, Besu, give me a valuable payload. And it's going to use very similar logic to the get work thing, where it's essentially bundling a bunch of transactions, doing a few computations on it, actually running, giving the post state root, gives it back to the validator, which is on the beacon node side, and it puts it into its beacon block payload, signs it, and broadcasts it to the network. And that's kind of the core of that functionality, that, like, pretty much like the ability to ask for a valuable payload is the core functionality, and to also insert payloads. So, like, I'm a validator and I didn't propose at this slot, but I see a block came in, and I'm the brain. I'm checking the proposer signature. I'm checking some of, like, the outer consensus layer stuff, and then I get to this execution layer thing, which is transactions stuff related to 1559 base fee. And I say, hey, execution engine, you're really good at this stuff. Tell me if this is valid. So I pass the payload over to the execution engine, and Geth or Nethermind, Open Ethereum, it runs the computations just like it would run a block today. It checks the post state root, it updates its local state, and then it essentially returns true or false, like, hey, was I able to insert this or not?
Right.
And that just becomes an additional validity condition on the beacon block itself. And then that state root is embedded in the beacon state. And so if you think about the Merkle tree, the outer beacon state, you have, like, the validators, and you have some historical stuff, and you have the execution layer state root. And if you dig deep into that, it actually goes all the way into all of Ethereum state. So it's really, I don't know, it's funny, like, the realization here is really, like, what did we build? We built a consensus mechanism called the beacon chain.
Right.
Let's come to consensus on stuff with it.
Right. Yeah, it makes a lot of sense. There's just the idea that you're coming into consensus, and it doesn't matter what you're coming into consensus on. And then, like, whatever you come to consensus on, then you use some state machine to actually, like, make meaning out of it.
And I said this before, but, you know, it's been a incredibly happy accident to have to have specialization, to have both in teams and expertise and software itself. And we might even see more of it. I think we've actually begun to see some of it with Flashbots. You know, what is MEV Geth? It's Geth, and then this, like, modification of this thing that they control, which they specialize in, which is the management of the mempool in a more sophisticated way, and the creation of very valuable blocks. And so, like, and they even want to, like, try to carve that out and make it a more modular piece of software so that any client can leverage it, you know. And so that all of a sudden you then have consensus layer, execution layer, and maybe even, like, transaction MEV layer.
Right. So MEV Geth is a piece of, like, if we were going to fit it into this model, it's a piece of the execution side of the puzzle. And it's basically taking a mempool as an input and creating a valuable block, and then passing it into the consensus.
Yeah, I mean, and additionally, they have some more sophisticated market mechanics, where rather than just submitting transactions, people can submit bundles of transactions for being picked up, because obviously how you tie transactions together can have different MEV properties. And so that's really the specialization there, is the modification of Geth's mempool to support bundling and to support a market for bundling.
Yeah. And one of the things we were going to talk about was MEV as well. So maybe let's just jump into that now. How does MEV evolve with the merge? And maybe actually, I mean, because we've also just had 1559, maybe there are some changes that are also going to play out right now, but how is MEV going to change in the next year as a whole?
That's a hard general question to answer, but I'll try.
Throwing you to the wolves.
I'll try and narrow it down. So just, starting with 1559, there's not a ton of impact with regards to MEV and 1559. The biggest one is just that every transaction on the network needs to pay the base fee. So that means that you just need to re-architect MEV bundles where prior to 1559, you could have, say, your first N transactions pay 0 gas, and then the last one pay the gas to the miner, or something like that. Now every transaction needs to cover at least its own base fee. So it's it doesn't change kind of. Oh,
it changes a little bit. So one of the design goals of like iterative MEV work is MEV minimization, and 1559 does do some of it. So it does reduce the magnitude of what a proposer can extract from a block, which MEV minimization is maybe a good target for multiple years to help with core security stuff, which we don't need to necessarily get into right now. But it does modify a little bit.
How does it do that? How does it lessen the amount of MEV that can be captured?
If it's less than the base fee, basically.
Pretty much.
Mm-hmm.
Yeah.
Because some of it is being burned
Right.
and isn't directly accessible by the
Right.
miner
Like
anymore.
previously you got all of the transaction fee. And so you got
Yeah.
MEV plus transaction fee. Obviously, like the way market mechanics work out, you might not
Yeah.
get all of that,
Yeah.
but
Yeah. That's true. That's interesting though, because especially like people, when they think about MEV, like everybody brings up like the 10 ETH MEV blocks, or like, the 100 ETH MEV blocks, because you see those like on Twitter. But I was looking at the Flashbots data, and it's something like 80 or 90% of the MEV transactions are less than 0.1 ETH. And so there is like a very large long tail of small MEV. So yeah, that's a good point. I'm curious how much of that is actually smaller than the base fee. And I think with the merge, there's a couple of things that change. The first is, in advance, or a short time in advance, who is producing the block. Whereas under proof of work, that's not something that's known, right? Like every block is basically random.
And you know this at the beginning of an epoch?
Yes.
yes, right on at the 0th slot of an epoch, which an epoch is 32 slots. I know the proposers for that entire epoch.
Yeah.
That is the
Yeah.
look ahead.
Yeah, so you can kind of know exactly like who will be the block proposer. The other big change is the set of block proposers is much bigger than the set of current miners, right? Like Danny mentioned earlier, any 32 ETH validator can be a block proposer. And I think that's something where probably in terms of MEV, like design structure, you're going to have to see like the most change. Like how do we go from like contacting 5 to 10 mining pools to contacting potentially like 100,000 validators, and just handling that. And the other thing I think is really interesting is, again, we mentioned that validators have a 32 ETH stake, and if you want to stake more than 32 ETH, you basically get multiple validators. So you might start to see cases where you can know in advance that a single entity controls 2 validators who propose 2 consecutive blocks, right? So say, I don't know, some exchange or some, like staking product has validators that happen to be the proposers for 2 blocks in a row. You might be able to have multi-block MEV strategies, where, you're like lowering the price on some DEX in one block and then, picking up something on the other block or something like that. And I think that's like a huge design space that's not explored yet, and won't be like necessarily a frequent occurrence. So I suspect we'll start to see like just, what are like the biggest MEV opportunities possible, and perhaps see those exploited across 2 blocks.
Yeah. So with this transition to validators producing blocks, how is MEV going to change? So on the one hand, that's a very positive development because it democratizes MEV, right? It's just every validator anyone who becomes a block proposer will get some MEV. And so what are the dynamics going to be there? Is everyone, do you imagine there being MEV tools that people run locally? Or will there be, for instance, services that you're subscribing to a service, and when it's your turn to be a block proposer, this service just gives you an MEV bundle, and you give it a cut because of it kind of figured it out for you, and you take the rest. Like, how is all of this going to shake out?
That's kind of what happens today, increasingly so with Flashbots and the way their market works. And we'd expect very similar port of that infrastructure into the proof of stake context. And I think a lot of that, although the number of participants is much higher, and so some of the mechanics might need to change, a lot of that is likely going to operate in a similar way, at least at first. And so that, although very sophisticated mechanism, very early in terms of like MEV markets, there's a lot of room for improvement, but that does help with the democratization of MEV, because otherwise you might expect very large pools that have R&D budgets to make MEV, they can get 10 times the MEV of like the home hobbyist. Then all of a sudden you see like massive centralization vector because you can be way more profitable. And so these open markets are very critical over time, and fortunately one does exist moving into the proof of stake world. There's a lot of work to do on them though.
It's a centralization vector because you just kind of accumulate more ETH over time, and you set up more validators, and your shares
or
of network increases.
I'd have a disincentive to be a hobbyist, and I might want to go with Coinbase because Coinbase has an MEV research group that is always on the cutting edge. It's kind of like high frequency trading. Like you either can play the game or you can't, right? And if you have a ton of money, you can play the game, and otherwise you just like cannot play the game. And so if you want your capital to be with high frequency traders, you have to just give it to them. You can't just like do it at home. Whereas if you have a free market of MEV being sold essentially to block producers, then you minimize that disparity there.
Yeah. How does the Ethereum network look in terms of who's actually running these validators and nodes? For example, there is a pretty strong hobbyist community, and yeah, what a person who is running a home staking setup, like who are they? Are people just kind of setting up a server rack at home and running this, or what are people actually doing there? And what percentages of the network are these different groups?
So first of all, huge props to the ETH Staker crew and the work they've done over the past year and a half to enable the hobbyist community. Obviously, that's been a huge design decision from like a fundamental level to be able to target low ETH quantities and things like that. But like they did a lot of the legwork to actually help the community learn and grow and understand hardware and build guides and all that kind of stuff so that hobbyists actually could be enabled. Who are they and what are they running? Hard to say. I know some of them. They seem like regular people. They're often running on NUCs, maybe called nukes, which are like just like kind of small PCs dedicated. Sometimes they have sophisticated setups where they have a universal, like a backup power supply in case things go down and like that kind of stuff. And some of them are even experimenting with Raspberry Pis. So the Ethereum on ARM guys are running a couple of validators on Raspberry Pis, which are like very less than $100 devices that are very resource constrained with success. And they plan on being on all the merge testnets to ensure that we can actually run fully merge client and a couple of validators on that hardware, which is pretty sweet. But it ranges. It's interesting because I know some very technically sophisticated hobbyist validators, but I'm also aware of just talking to people on the internet. There's a lot of people that like, this is by far the most technical thing they've ever done. So they're like ETH enthusiasts. They've been excited to stake for a long time. And then they just rolled up their sleeves, read some guides and jumped on a command line for the first time and got their stuff running. And fortunately, shout out to Somer. There's some like really, really great guides on setting up firewalls and kind of getting past just the basic client configuration to get this stuff running. But I don't know, it's been pretty cool to see that grassroots effort. I think the counter to that is that, I'm looking at least the breakdown of known deposits, and we're probably like, although there's like whales and stuff in here, hobbyists probably make up more than 1/3, but probably don't make up more than 40% today. And then so we're looking at something like 60% are some much larger players. some big ones. So like Kraken. Oh, actually, there's a classification on this website I'm looking at here. I'll share it with you. Called whales, which is 9.38%, and I assume that was an exchange. So actually, if you include whales as hobbyists, which is probably fair, they're independent actors, we might exceed, maybe 45%. It's hard to say what's in this blue block of others, but we have some exchanges which offer staking services, and then we have some staking institutions that's like their primary thing. And a big mix around here, obviously some larger ones, and then many smaller actors. And then this.
So what is, how, and either of you feel free to take this, but how do we think about the incentives of someone staking on their own? Why would someone actually do that given all of the work that it involves?
So it's not that much work. One, it's fun. I mean, that's not a good enough reason. So any of these staking institutions are going to be.
It is fun. I mean, and that's a good, like, being, especially, in a new emerging thing, like being a part of the community is a very positive thing. Yeah. I would say that's
very powerful. I mean, like to just learn and do and be a part of this decentralized thing. Like, obviously, I don't think there are incentives for a reason to help incentivize people actually doing this, but like, but for the first while, like, that's a pretty powerful incentive in and of itself. But totally. Any of these large players that you could put your capital up with and stake, they're going to be taking some amount of fee. And so it's a trade-off. Like, they might be taking 25% of your staking returns, which maybe that's worth it. But there's also there's risks associated. So like we have this thing on Eth2 on the Beacon chain called slashing, and that's essentially if I do something provably cryptographically nefarious, which essentially it comes down to contradicting myself. Following the protocol, you'll never contradict yourself. You're allowed to change your mind an epoch later, but you cannot forget that you made a different decision. But you can be slashed for these provably nefarious things. But the amount that you're slashed is actually related to the amount of other people that were slashed recently, because you actually have to have at least a third of the network, oftentimes even like 50% of the network, to create like a network fault, to create two viable histories. So if I'm just slashed in isolation, like I run my node at home and I got hacked, or I do something really stupid with management of my keys, I'm going to be ejected from the validator set, but I'm not going to lose that much money if it's not correlated with other people. Whereas if I go to an exchange and they're 20% of all the capital being staked, and they have some sort of like insider threat or a hack or do something where they have a mass slashing, they're actually going to you lose the percentage of the network that was slashed recently times 3, such that if 1/3 of the network was slashed, you'd have maximal punishment of 100%. So if I was if 20% of the network was slashed because of some massive exchange hack or something like that, they'd lose 60% of their capital. And so there's not only that like fee, there's also a lot of other considerations in if I were to select, or if I were, if I did select an exchange, and which exchange or which institutional player I chose. It's not just pick the biggest one with the best reputation.
Yeah, I always really liked that idea of the amount of slashing being correlated to what portion of the network is getting slashed. Because there are other reasons. I mean, I would balance that with, okay, I'm going to run this staking setup at home. There's always a chance that I mess it up compared to a professional doing it. If this big reputable exchange messes it up, there's a chance they'll make me whole because their reputation is on the line. So there are, I think it's probably hard to think about how these things shake out in the short term. And it's more, what kind of they converge on over time, especially maybe after things go wrong a few times and people start to see what patterns there are.
We call them anti-correlation incentives, and there's a few others there, like with respect to liveness and some other stuff. But the problem is they're penalties and tail risk scenarios. And we are very bad at assessing, the probability and impact of tail risk scenarios. And so I bring them up a lot because I think they're very clever, and I think they're good incentives to have in place. But I think that it's very difficult for the average person to make a to assess the judgment call that those anti-correlation incentives maybe like should push you. And so you're right. You mentioned maybe you have to see some of the bad things happen before people actually are able to like make the decisions with respect to them.
And what about staking derivatives, or, you know, let's say I'm most familiar with Lido, which I actually quite like the way they've progressed on the protocol. I mean, my understanding of how it works is that they're, you know, they on the one side, they allow you to deposit into their smart, you know, into their system. And on the other side of it, they kind of funnel this into multiple staking operators. So, you know, they're actually, you're not kind of taking just a correlated risk with everyone else who's under their system. And also, I mean, just having followed their progression for a bit, I sense that their vision is to build a truly decentralized system over time, right? Where anyone can kind of become a staking operator. There's reputations involved. You can, you know, so it kind of evolves into a middleware layer, and others might be doing similar things.
Yeah, that's what I call it. I call it like they're not a staking pool. I mean, they allow for pooling, but they're more of a staking middleware. I think that's a staking tokenized middleware that does round robin allocation to underlying staking providers for diversified risk pool for a staking derivative that has yields.
And I think it's worth noting like the pros and cons, like especially today, like there is still a fairly high element of trust in Lido today because of like what the protocol, you know, allows them to actually decentralize. And I know the team has been working on some proposals for, say, withdrawal credentials and whatnot that could help make it a bit more decentralized. But, you know, you do have like this extra trust assumption and this basically this extra cost. So I forget what the exact percentage is, but obviously Lido, like any other staking provider, will take a cut of the rewards. And, you know, like the upside is, one, if you don't have 32 ETH, right, it makes that accessible, right? And you kind of hedge your risk with like a single provider, like Danny mentioned. So it makes it easier to, you know, get access to basically staking rewards without having that minimum amount. And two is, yeah, you do get the derivative token back, so the staked ETH, which you can then use, right? And that I think will be interesting to see in the medium term, like, you know, how much people value the fact that they can use the stake token to do other things versus just leave it in the beacon chain alone.
So what are the kind of second order effects of this? Like if more and more of the stake moves to systems like Lido, and then people, I mean, yeah, what sorts of ramifications does that have for the network at large?
It's complicated. It certainly has security implications because you could potentially leverage these assets in different ways so hedge against essentially an attack that you might be conducting in another context. I think that withdrawal delays, which exist, essentially there's a queue on exiting and being able to get capital out, does protect against a lot of this. If you could instantly join staking, get some asset, short it, and simultaneously conduct an attack and also get the assets out, like I think that would be a much more bad situation. But I don't know, I need to think about it more. There's a lot of people thinking about it, but staking derivatives definitely complicate the naive security assessments.
I do think, yeah, there is like something good in that it is middleware where, you know, the people who would have to conduct the attack are not necessarily the people who deposit the ETH, right? They're the people who run the validators. Right. And so these, you know, you might be able to have a system where, say, they put up like a bond or something, or, you know, and to be fair, a lot of them are actual legal entities, right? Like, especially I believe in Lido's case, like most of them are known, you know, companies and whatnot. So their incentive to, you know, it's not just like some random whale can come in to Lido, put in, you know, 100,000 or 1 million ETH and, you know, run an attack and then withdraw it immediately. So I think the more layers and delays that you add in the system, you probably reduce some of the risk, or at least increase the coordination costs to have a successful attack. And that's valuable.
Yeah, very interesting. And yeah, I mean, I also feel like at least in the early days, there is a way in which if you're staking directly or through, more directly through a staking pool, you feel that you have the skin in the game, right? If something goes wrong and you get slashed, you lose funds yourself directly. Whereas through a system like Lido that's aggregating, those sorts of things are socialized across the system, right? So you feel it less. Maybe you wouldn't even realize that there's been a slashing because whatever, you're just kind of not seeing the incremental changes.
So I will say diversity. So these things will exist clearly. Lido is very popular today. Lido, unfortunately, is pretty much like the only option. Diversity in on-chain staking pools and on the spectrum of decentralization. There's many different aspects you can decentralize with respect to these types of systems you would build. And I would hope to see massive amounts of experimentation in this. And I think that if you're listening and you're looking for a business opportunity, make a competitor to Lido. It'd be healthy, I think, for everyone to see that.
Yeah, it's interesting, this pattern that seems to keep repeating in the space where there's an early leader and no one else kind of attempts to do the same thing, even though
to be fair, there was another early leader in this
proven.
case, right? Like I think Rocket Pool.
They were never a leader. They never launched.
Yeah, and I think this is like a really interesting case study. We were talking earlier about like pragmatics versus idealism. Right. I think a lot of the Rocket Pool seems to have taken the approach of like wait until the protocol allows you to be sufficiently decentralized to launch, whereas Lido was like launch with whatever is available and hopefully decentralize over time. And so I think hopefully we do, as more and more functionality is enabled and there's kind of a bigger design space, we see more people coming in and experimenting with that.
It's funny because on the L1, you like people sometimes argue like somebody else is going to come and eat Ethereum's lunch, which like maybe it will. Yeah. We'll see. But Ethereum launched early, and with design flaws and with a consensus mechanism that wasn't perfect proof of work, and is working on iteratively making it better. And so in that sense, I think that often saying like Ethereum's not out there making moves is wrong, because they kind of did the Lido thing in that they launched as early as possible. Well, it was honestly they're running out of money and it was time to go.
Good thing we didn't wait for proof of stake, right?
Yeah, and I mean, I'm still eager for Rocket Pool to launch. No negativity there, but I would have hoped that it had launched already, and I would hope that there are many other interesting options coming. There's this development called secret shared validators, which leverage some of the cool properties of BLS signatures and threshold signatures to be able to take a single stake, so a single validator, and actually split control of it amongst a number of entities that have its own kind of safety and liveness properties in controlling that validator. And these have actually become relatively sophisticated. They're on testnet now. They've been hammering on them for a while. And I think that actually opens up a lot of interesting companies and maybe interesting like DAOs and things to build with these. So I do think we're going to have a second wave towards the end of this year of some interesting options coming out in this layer. And I'm super excited.
So the idea being, like, I guess one of the value propositions of a system like Lido that we've been talking about is you could have less than 32 ETH and participate in it. And this is kind of baking that into the protocol where a validator is still going to require 32 ETH, but multiple people could come together to put that together and govern it in between.
Yeah, essentially you have a consensus mechanism for your validator that then participates in the consensus. Which there's a lot of different like ways you can design that, but there's this R&D group working on secret share validators. They're on testnet, and you can do it today. So you know, there's a few different things you could do with it. You could join with 3 friends and split it down the middle, and do a 2 of 3 on secret share validator. Each of you runs a node, and they come to consensus in it, and no one has to trust each other fully. You have liveness properties if one of you goes down. But another reason you might use it is you might be a institutional staking provider and find it actually a more secure setup to split your keys in parts and have mini nodes and redundancy and stuff. So it opens up a huge design landscape.
This is a more robust way of building a system where you have backup keys. Yep. And because right now that's one of the main reasons people get slashed, right? Is they haven't designed their systems well.
Don't put the same key in 2 places and tell them they're in charge. It's a bad idea. Go offline for like 10 days rather than trying to make a redundant setup.
Actually, that's something people have asked me, and I think Danny, sort of, you take it 2-3 minutes. Like, you know, a lot of individual validators are like, well, what if I move, right? Like I'm moving from, you know, New York to San Francisco, and like my validator is going to be offline for 2 weeks. Should I even bother setting one up? You know, like, can you talk a bit more for like an average user? What are like the conditions under which they're like expected to be profitable? And yeah, like,
so assuming the network is finalizing,
yeah,
which it pretty much always is. You cannot take that for granted. If AWS goes down and we find out too many validators on AWS, they're all going to lose a bunch of money because it's not going to finalize. They're all going to be correlated. Don't be on AWS. Be uncorrelated. Run it at home. But assuming the network's finalizing, when you're offline, you stand to lose. It's actually about 3/4 that you would have made online. Just call it 1-to-1 for easy. So like, if you're offline for a day, you lose a day of profits, like literally, not just opportunity costs, your balance goes down a little bit. Or if you're online for the day, it would have gone up linearly. And so what you can think about it is, if I'm offline for a day, I come back online. After 1 day, I've gone down a day, I've gone back up a day, I'm at 0. So if I was offline for 2 weeks, I would come back online. I'd be online for 2 weeks. I'd be back where I started. It would kind of amount to 4 weeks of not having a return for that year. So, you know, 4 out of 52. So that's like a 7% reduction in your total profitability for the year, but you're still definitely profitable. Even if you're offline for half the year and you came back online, you'd be like net 0 for the year, which try to be online more than that. But it's as long as you're not correlated with other people, like with a lot of other people going offline, so you're not with a big pool, or you're not on AWS with a big outage, like you're not going to really lose that much money. And so if I was offline, I knew I was going to be offline for 2 weeks. 2 weeks is on the range of like, that would kind of hurt. Like I'd probably put in the amount of time to maybe power down, get a non-AWS cloud instance, and run for 2 weeks while I move. But you need to be careful that it's power down my node, export the slashing database, power up my my cloud instance, then power down my cloud instance, power up my node. You never want your keys running in 2 places at once. And so like in the 2 week time horizon, certainly in the month time horizon, I'd be like, okay, it's worth like making sure I'm live in the middle. But if it was 5 days, like I you know, that was the move, then I personally would not I would power down my validators and I would turn them back on in a new location. Because you know what, 10 days out of the 365 in the year, you know, I'm looking at like not losing too much money.
Are there, I think I saw you somewhere else saying that there's a new feature called doppelganger detection. Is that relevant at all here?
Yes. So this came out of, I think, Donkrid and Superfizz both had this idea around the same time. And Superfizz coined the term doppelganger.
Like all great ideas that arise in multiple places.
Equals MC squared. A few people did that one, right? And so doppelganger detection, that term coined by Superfizz, is now a feature supported by at least a few clients. I know it's supported by Nimbus. I know that in the 1.5 release on Lighthouse, which is coming out soon, it will be supported. And it's a default where I turn on my node, and because safety failures, me double signing, is way worse than liveness failures, I actually don't, like, my node turns on and I sync, but I don't start signing messages. I just listen for a second. I listen for, 2 or 3 epochs, and I see, is anyone else signing messages with my same key? If so, shut down. If not for a few epochs, that's a good sign that, like, I'm the only one running these keys. I didn't accidentally turn on my cloud instance while my home node was still running, and I continue on without any issue. There's usually like a CLI that would be like -- unsafe, capital letters, disable doppelganger detection XYZ 1010, like something that's really hard to type, that if you know you're the only one running the keys, you can like bypass the 2 epoch wait, and not deal with it. So there's even in the UX of not being slashed, especially for hobbyists, things are getting better and better.
Well, gradually bringing this to a close, I guess I'm kind of curious to go back to that question of what is happening now until the merge. And so we know that there are, there's 2 pieces of software that have a relatively clean way that they're going to interface with each other. Is the work now for these different clients to kind of build out this shared interface and this shared spec, and then set up a test net and go from there? Are there any kind of big unsolved problems that need to be tackled in the meantime? What does that kind of future roadmap look like?
Yeah, so one thing that's really promising in the direction of the merge is we tested this back in May. So when this idea of combining the current Eth2 client with Eth1 clients kind of started to get traction, we wanted to be sure it actually worked in practice. I personally was pretty skeptical.
I knew it was going to work.
Yeah. So in May, there was this month-long hackathon organized by Proto Lambda called Rayonism. Yeah. And the goal there was just can we get this to work on a testnet, right? Like, just hack together, all of the clients from Eth1, all of the clients from Eth2, make the minimum set of changes and get this working. And it actually did work. So Danny was right here. We got every permutation of Eth1 and Eth2 clients, I think except one of the Eth1 clients. But basically the 12 permutations worked. And they were running on a network together, and producing blocks. So that was awesome. It kind of validated, that this architectural design is sound and we should go with it.
So people were running each permutation as a separate node, and they were all coming to consensus together on these blocks moving forward.
So we have to come up with a bunch of different hybrid names, like Geth House and Prism Mind,
Yeah, so I think, that was, kind of the big technical de-risking of like, does this approach generally make sense? Over the past months, both the Eth1 and Eth2 teams were pretty busy because we had London going live, and then Altair is about to go live in the, I don't think it's been scheduled, but soon.
And Altair is a hard fork on the consensus
so it's the first beacon chain hard fork. Has some nice to have features, but it's also just like putting in place the ability to fork this system live before we have to fork it with like, $1 trillion of value behind it.
So yeah, now we have a ton of engineering work to do, and Danny shared this checklist in the chat, which basically goes over it. But it's really kind of getting this to production readiness, getting this tested, figuring out, so there's a few small kind of details we still need to figure out, and decisions that need to be made. But the general architecture is set, and now it's just, getting it to a spot where it's production ready. On the execution side, given that London is out, this has now kind of shifted to the main focus, and client teams are starting to work on it. And similarly, once Altair is out on the consensus side, then mostly those teams kind of work on it as their main priority as well.
Right. And I would say, yes, all the normal things like refinement of specs, writing of a lot of tests, test nets and all that kind of stuff. But I think my estimation is the long tail on this is like testing and security. It's it's having test nets run for long enough. It's hammering them with all sorts of stuff. It's like turning half the nodes off and not finalizing for 3 weeks just to see what happens, like all sorts of that kind of stuff, because it's not like a continuous, it's really the value the beacon chain is securing ratchets up quite a bit. And so getting it right is very important.
Are we experimenting with any new mechanisms around security and auditing and bounties and that sort of stuff?
So I would say we should, triple the bounty program at least tomorrow. That's a conversation for another day. But I think that ratcheting up the bounty program makes a lot of sense to me. I think there's the EF capital that the EF has for this kind of thing, and what we can catch now is way better than what we can catch 5 months from now. So that we have a couple of new red teamers that are focused very much on the merge. These guys are onboarding now. They're super good and are just working on breaking things. We're still have our fuzzing infrastructure on both sides of consensus layer, execution layer. We've been talking with a couple of people that are looking into fuzzing, like more creating these like deterministic networks and hypervisors and fuzzing actually the network rather than an individual client. So there's a lot of stuff going on. There's another guy is actually looking into doing network load tests. So like actually put a huge budget around creating pretty large networks distributed across the world, and hammering them with things or making slot times really short and that kind of stuff, and just kind of seeing what shakes out. So there's a lot of stuff. All the basics certainly be there, in that we're going to get some cross-client testing, infrastructure, testing vectors in place, and we're going to be building test nets and hammering them manually. But lots, if you're interested in this stuff and you have an idea on like a security proposal to help with the merge, like holler.
Yeah,
sky's the limit.
And how does it feel to be working on this? I feel like there's something special about the merge coming up and this particular hard fork, in a way that, I'm always excited about the developments, but this has been a long time coming, and it's one of these moments that we've been seeing from years ago.
I like the focus. So I don't know, maybe this is like working on Eth1, but like a lot of working on the protocol execution layer is like, we have like 30 EIPs to sift through and like try to think through all of them, and like how do they like overlap or non-overlap, and it's kind of refreshing with the merge. It's like this one thing, right? Like this one target, and it is huge, right? It's bigger than like the sum of probably those 30 EIPs we usually look at, but like, yeah, it's really refreshing to have like one focus and having so many teams kind of aligned on it. Yeah, I like it.
Yeah, I mean, bringing proof of stake to Ethereum mainnet is almost the only thing I've thought about for years, to be quite frank. So it's exciting. I mean, on the one hand, I'm like, it's just like pretty normal because what I've been doing for many years at this point, but it's also actually, with the launch of the beacon chain last year and actually seeing it come to a head as we get the merge ready, I'm excited.
We'll have some good celebrations, I feel, after this all goes down.
I definitely celebration in order.
We maybe need to just organize a DevCon around it. Who knows? Maybe the stars align.
Yeah.
I hadn't actually thought about that, but maybe they will.
Yeah, merge right at DevCon.
A lot of uncertainty in global travel, but I can tell you one thing: the merge is happening.
Yeah. Cool. And maybe as the last thing, if people are listening to this and want to work on these problems on the protocol layer, where are the most interesting problems? Where would you kind of encourage people to look? And we've talked through some of them. I mean, the most recent one that came up in conversation was around security and really making sure that this network is going to be secure. But what are the other areas that are top of mind for both of you?
So I guess to answer your first question, where should people look? We have, there's ETH Research has kind of a random list of posts about problems and solutions. So if you're totally new and like, I don't know, just want to get a feel for where things are at, that's maybe kind of a good thing to skim and see if anything there kind of interests you. We also have a R&D Discord where there's more kind of synchronous conversation and kind of iterative conversations happening about most of the stuff that's discussed there. So if you do want to contribute and get involved, then joining the Discord is probably a good place. In terms of the problems themselves, so I think we discussed a lot of the ones with the merge. And like Danny said, right, he's been thinking about this for the past 3+ years. I think there's a lot of big things we're going to need to do in the next 3 years after the merge. So that's also like a good area for people to come in and start contributing. Off the top of my head, you know, the sharding implementation is one. So getting shards up and running is a big area of work where, you know, more people will definitely make an impact. My personal kind of pet problem is state growth. So I think once with 1559 and the merge, I think we're 2/3 of the way to Ethereum being sustainable, that like if we didn't touch it for 10 years, we'd probably be good. The last part that's missing is state growth. So right now there's kind of no limits on the rate at which the state grows on Ethereum. There's been tons of proposals over the year to address this. The gist of it is it's hard to do because Ethereum is already live. It would be very easy to fix this problem if we were starting from scratch on a new blockchain. And there's more and more kind of concrete proposals that seem realistic, and there's a lot of value in having kind of researchers who have like engineering skills start to actually prototype these and see what breaks and see what the edge cases are. So yeah, if I could direct people to one, it would be state growth. Yeah, and you'll be busy for the next 3 to 5 years.
And this is more abstract, but just the doors are wide open. Like, if just show up, there's interesting problems, work on the problems, ask questions, fix typos on GitHub, and like it just kind of spirals out of control. Like the next day you're going to be talking to your crypto hero. I mean that earnestly. Like, you know, if you're interested in this stuff, just jump in. There's literally an infinite amount of work to do.
Yeah, it's unexpected, I'd imagine, that, you know, just going to the ETH R&D Discord in the main channel, there's, you know, 6 people going back and forth, and they're literally the people building the future of Ethereum, and you could just join the conversation right there.
That's wild. Yeah. And again, I'll echo what I said before. Security and testing. If you have a skill set that you think is relevant to getting this stuff done, knock on my door. We can find something for you to do.
Well, we can call it here, I think. This was really fun.
Sweet. Yeah. Thanks. Thank you so much for having us.
Yeah, this was great.